Hey everyone. So part of an equipment rental business is knowing how to repair things when things go wrong. You can always call a repairman or take it to a repairman, but particularly with these machines, they're few and far between, and the cost can rack up significantly. So over the years, I've learned to kind of work on these and diagnose things and fix them myself. So this video is going to be a little bit different today. I want to show you an issue I had with this machine right here and how I diagnosed and repaired that myself and saved myself probably $500. So just to start off with, this is a Frosty Factory 217A. I had this machine on a long-term lease, and they called and they said that the left side wasn't freezing. The right side was completely freezing, but the left side wasn't freezing. So I went and switched it out with another one real quick, brought this one home and worked on it and found and repaired the issue the other day. But I want to show you all the process of that because I don't think there's many videos available for this, or at least nothing that I could find while I was learning this process on how these things are fixed. So if you'll give me just a second, I will get this thing stripped down, opened up, and show you the process I went through. Let me snap my fingers and we'll be there. Ready? Wow, that was easy. The first thing I check, the thermostat. Rule of troubleshooting. Start with the simple stuff before you go chasing anything complicated. I tested for continuity. Basically, I checked whether there's a clear path for electricity through this component or if it's broken somewhere. A good connection reads close to zero, anywhere between 0 and about 1 ohm. That tells you there's almost no resistance, so current can flow through freely. Most meters will also beep to confirm it. Here's the thing though, I didn't know this at the time. Turns out this thermostat is only in the circuit when the machine's running in refrigerate mode, not freeze mode. I was troubleshooting a freeze side problem, so this component was never actually part of the circuit I needed to be looking at. Checking it didn't hurt anything, but it also didn't tell me anything useful. Good lesson early on. Know which mode you're actually diagnosing before you start testing components, or you'll spend time on things that were never in the path to begin with. Next, I moved up the line to the solenoid. But before grabbing the meter, I checked for something else first. Something I've actually run into before in these machines. Sometimes the issue isn't electrical at all. It's the capillary tube right past the solenoid getting clogged. When that happens, you'll usually see the line flash freezing over and over, right up to the blockage point. That's a sign that the filter dryer is starting to fail and it's not a DIY fix. That needs a technician. If I'd have seen that, I'd actually know the solenoid was working fine. Refrigerant was flowing. It's just getting stuck further down the line. But I wasn't seeing any of that here. No flash freezing, no signs of any blockage, nothing like that. So that ruled it out, and I moved to testing the solenoid itself. Quick net rundown on what it does. It's basically a valve. When it's energized, it opens and lets refrigerant flow through the line to keep the cycle going. No power to it, no flow, and no cooling. On the good side, 120 volts across the terminals. The circuit is complete. Power in, path back to neutral, everything closed and working. On the bad side, nothing. No reading across the terminals at all. Circuit wasn't complete somewhere, but I still didn't know if the solenoid itself was bad or if the fault was further upstream. To rule the solenoid out completely, I swapped the wiring. I took the good side's wiring and connected to the problem side solenoid. If the solenoid activates with the good wiring feeding it, that proves the solenoid itself is fine and the problem is upstream. It worked. The solenoid kicked on. This confirmed the solenoid was never the problem. Something further up the circuit was. This machine wires the solenoid, the time delay, and interlock relay together as one group per side. So next test was the time delay relay. This one took some digging to actually understand. While the relay is in its delay period, before the timer runs out, you'll read 120 volts across its terminals. That's because the contacts inside are still open. Nothing's flowing through yet. When a switch is open, your meter reads the full voltage sitting there. Then you hear a click. That's the timer running out and the contacts closing, and the voltage drops down to about 2.6 volts. Once the contacts close, current actually starts flowing to the solenoid, and most of that voltage gets used up by the solenoid itself instead of sitting across the relay. That small leftover reading is just normal contact resistance. That whole pattern, 120 volts, then a click, then a drop, is exactly what a healthy relay should do. This one was working exactly as designed. Everything downstream had checked out. The solenoid was good. The time delay relay was working exactly as it should. So that really left one place to look, and it was further upstream. It was the mercury switch. Quick rundown on how the switch actually works. As product in the barrel freezes, it thickens up and puts more resistance against the beater. That resistance loads up the drive motor, which twists slightly against spring tension. As it twists, it tilts this mercury switch, and the mercury inside physically shifts to open or close the circuit. That spring is what controls the whole thing. It's what resists the twist and pulls everything back into position. Without it, there's nothing holding that switch in its normal resting state. It just sits wherever it lands. When I went to inspect the mercury switch, I found this spring was broken. No spring, no tension, no contact, which means no power ever reaches the timer, which means the solenoid never gets its signal. One tiny broken part and the whole chain downstream goes dark. So I popped the new spring in, reassembled, and everything worked like a charm. I pulled an old invoice from Taylor Freezer Services that I had used sometime last year just to see what the rate was, and it looked like they were charging an 150 an hour plus $150 travel charge just to get someone out to me. Realistically, this would have been an hour of labor plus the part plus the travel fee. Call it $300 to $350 total if everything went smooth and they diagnosed it fast. Instead, it cost me a spring and about an hour of my own time. That's the reality of running the machines out on lease. When something breaks, it comes back to you one way or another. But if you're willing to learn how they actually work, you can handle a lot of this yourself instead of eating a service call every time. Every repair like this pays for itself the next time it happens. If you want to see how I'm turning my frozen drink machines into a full time business, hit the like button. Also, subscribe and go check out my other videos. I'm documenting the whole thing, the good and the bad. And if you ever run into something like this yourself, or you've got a machine issue you're trying to figure out, drop it in the comments. I read all of them, and it might end up being the next video.